Okay, so in this video then, we're going to run through a few little exam questions based on electron structure. Now, the majority of these, in fact, I think all of these that I've got here are multiple choice questions. They tend to pop up as little one markers. They don't tend to be in-depth questions, and this is mainly because there's not a great deal they can ask about it. So in terms of basic electron structure, it's all to do with knowing the difference between subshells, orbitals, shells, and how they build up. So these are your common types of question. They'll give you, for example, I don't know, something like this: how many orbitals are occupied in a silicon atom? Now, in order to do this, obviously we should need to look on our periodic table and work out how many electrons that silicon actually has. So quick look on the periodic table. Obviously, if you have one, look at your own. You find that silicon has an atomic number of 14. So silicon will have 14 electrons, which is a great start. And now we simply need to build up our diagram as we would anything else. So remember that we start at the 1s at the bottom, and if it helps, you can draw the orbital out. So 1s, there's 2 electrons in there. Then you have the 2s, again, forgive my squares, that's 4 electrons. Then you'll go to 2p. Now remember, the p shell, or the p subshell, has 3 orbitals. And of course, all of these will be filled. Okay, just remembering they fill up individually first. And we get 6 there, so we've got 6, 8, 10. And now we go up to the 3s. Again, the 3s only contains 2. So here we are. So we've got 2, 4, 6, 8, 10, 12. We only have 2 electrons left to put in, and we're going to put them in the 3p orbital. Now, the question is, where do they go? Now, we mentioned a minute ago that this is where the trap will be in the question. I have 2 electrons to place, but depending on where you place them, depends on which answer you get. So I have 2 electrons to put in. The first one will obviously go into one of your orbitals. Now, if you were to fall into the trap and put it paired, you'd get the wrong answer, because based on the principles of how you fill electron shells, you have to fill them up separately or individually first. So this means that you have 2 orbitals occupied in the 3p instead of 1. So now all you have to do is count the orbitals. We have 1, 2, 3, 4, 5, 6, 7, 8. And so the answer is C. If you had paired them up by accident, you'd have ended up with B, which is 7. And this is the big danger with multiple choice questions. They'll always give you answers that you could get wrong. Okay, that you could get potentially if you mess it up. So just be aware of that. Okay, you have to put them in separately first. If you don't, you'll end up with the wrong answer. Now, moving on then, a very, very similar question. Which element has atoms with the greatest number of singly occupied orbitals? Now, just to, that's a very important key word there. So a singly occupied orbital looks like that. Okay, a single electron within the orbital. Now, again, you've got 4 options here. Now, conventional wisdom will tell you that you need to spend all your time now drawing out the electron configurations like we've just done for the above example. However, you don't need to do that. Okay, you don't need to do that because it's only talking about singly occupied orbitals. So all the orbitals that are full are irrelevant. And that means that, for example, carbon, if I was to draw the electron configuration for carbon in shorthand, it would be what, 1s2, 2s2, and then 2p2 as well, I believe. There you go, so you got 6 electrons. That's great. Now, are we going to draw all of that? Of course we're not. The 1s doesn't matter, and neither does the 2s, because they're full. And if they're full, we don't care. The only one that matters in this question is the outermost orbital. Orbitals, I should say. The subshell is the outermost, the furthest along, because those are the only ones that can possibly be singly occupied. Because everything beneath it has to be full, and by definition, if it is full, it can't be singly occupied. So for carbon, the outermost subshell is 2p2, which looks like this, a bit like we did earlier in our silicon question. You've got 1, and 2. So carbon has 2 singly occupied orbitals. Go to chlorine, same idea. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Do we need to draw all of that? No, because everything before 3p is irrelevant because it's full. The outermost shell is 3p5. Now, if you draw 3p5, again, you will get something that looks like this. 1, 2, 3, 4, 5. So chlorine only has 1 singly occupied orbital, which means chlorine cannot be the correct answer as carbon has more. Move on to calcium. Again, if you go all the way through, you'll end up at 4s2, which is its outermost occupied orbital. Okay, again, it's a bit of a trick. It's a bit of a time waster. You don't have to draw the whole thing out. Calcium's 4s2 is the outermost orbital. This one's easy. 4s2 is completely full, so there are no singly occupied orbitals in calcium. And D, again, they give you gallium. Now, gallium's got 31 electrons. Does it matter? No. And it doesn't matter because the outermost electron is in the 4p. Everything else is full, so even the 3d, which includes the transition elements, we don't care about it. It's full, so we don't need to worry about it. They'll put this element in here just to try and confuse you. 4p1 is the best gallium has. I don't even need to draw this out really, but I will anyway. 4p1 looks like that. It's only got 1 singly occupied orbital, so gallium is also incorrect. Carbon is the correct answer as it has 2 singly occupied orbitals and not 1. Okay, trick to these multiple choice questions. I'm going to mention this a lot through these videos. Don't get bogged down time wasting. Okay, there are simple ways to work out these questions. You don't need to spend ages figuring out, what the electron structure is in its entirety when only the outside shell matters. Okay, right, number 3. Element X has a configuration, 1s2, 2s2, blah, 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 up to 3p4. What's the formula of a compound formed when sodium reacts with element X? So just a quick bit of reminder then. You have a periodic table in the exam, so use it. Okay, sodium is in group 1. Okay, because it is in group 1, okay, it will form a +1 charge. That is important because what we need to figure out now is what element X is. Now, if you really want to, this is one of these things, you can just look on the periodic table and see which one it is. Because if you know how many electrons there are, 4, 6, 12, 14, 16 electrons, you can have a quick look, and element X is very, very clearly sulfur. At this point, the question becomes fairly easy. But it's about realizing that sulfur is what should be a 2- charge. If sulfur is a 2- charge, then that means you'll need 2 positive sodiums to balance it out. So what you'll need is Na2S. Or in this case, Na2X. Okay, I'm being a bit cheeky by just calling it sulfur. You can do this as well, by the way. There's no reason you can't just figure out the element. It has to be matching up. So again, sulfur's in group 6. It requires 2 electrons. Sodium can only give 1 as it is in group 1. Therefore, you have 2 sodiums to every sulfur. Therefore, the answer is Na2X. Again, that sort of question, if you get that in an exam, it should take you about 10 seconds to answer, realistically. Once you figure out the trick that element X is sulfur, it's basically asking you what the formula of sodium sulfide is, which should be a fairly straightforward idea. Right, final question then, I'll quickly run through this one. In the diagrams below, each box is an orbital and every electron is shown as an arrow. Which is the correct arrangement in an atom of carbon? So at this point, it's basically spotting the error. So we know that carbon has 6 electrons. That's our first, that's our big thing. That's our first test. So, if we go to, basically the best way to go to this now is go through the answers and figure out if they're right or wrong. You should hopefully see from first glance, this is not going to be a hard question. So first one, 1s2, 2s1, they're missing an electron. The 2s, quite clearly missing an electron, so A is quite clearly wrong. Okay, the electron should be here and not here, just to spoil the correct answer for you there. If we go down, again, they've made the same mistake. They've missed out a 2s electron, so it can't be B. Now, so it's between C and D, which is fine. The only difference between C and D, okay, they filled the 1 and 2s correctly, so that's fine. The only difference is the arrangement in the 2p. In the first one, they've paired them together. In the second one, they've separated them. Hopefully, you should know, based on the order of electron filling, is that you have to fill them separately first. So the answer cannot be C, and the answer is D. So there you go. Nice and straightforward. Electron questions typically don't have a large scope. They only ask a small range of things, and they are generally quite straightforward. So there you have it. 4 questions on electron structure. Hopefully that has been a bit useful.